Okay, guys, welcome. Today we're going to talk about a basic intro to composition of functions. There's a couple things that I would like to be able to do by the end of this section. The first thing is that you should be able to combine two different functions using the usual algebraic operations, which means can you add two functions, can you subtract, can you divide, can you multiply two functions. We'll then talk about one thing that's very important when it comes to pre-calculus and calculus, and that's the idea of the composition of two functions. And then we'll be able to write a complicated function as the composition of some more simple functions. And we'll also talk about how can you look at function transformations, similar to what we did in the last video. How can you now express that as a composition of functions? All right, so let's go ahead and we'll get started. All right, now the sum, difference, product, and quotient of two functions sort of work exactly like how you would think they would, right? So if you want to add two functions, essentially what you're going to do is you're going to combine like terms. Right. In the second one, right, when you're going to do f minus g, it's essentially going to be combining like terms, but you have to first remember to distribute the negative first. All right. When you multiply, you can think of that sort of as distributive property. And when you divide, what you want to do is after you write, and of course you need the bottom function to not be 0, but when you divide two functions, what you want to do is factor and simplify if possible. All right, and of course, if you can't, then you would just leave it as is. All right, but we'll look at a couple of examples of this. Okay, so first of all, in part A, we have that f of x is square root of x minus 3, and g of x is square root of 8 minus x. All right, now in part A, we want to evaluate f plus g of 5. But what does that mean? That means that we want to find f of 5 plus g of 5, right? So if I plug in a 5 in my f equation, that's square root of 5 minus 3. And if I do the same thing for g, that's a square root of 8 minus 5. All right, so I just went into each function and replaced x with the number 5. All right, so now if I simplify this, the first one will become a square root of 2, and the second one will be a square root of 3. All right, now we haven't really talked about how to combine these terms, but it turns out that you can't with these two. That's the best you could do here. All right, now in part B, they want a formula for f plus g just of x this time. But again, by our definition, this means that we want to find f of x plus g of x. And f of x is just square root of x minus 3, and g of x is square root of 8 minus x. All right, and it actually turns out that we can't do anything else with this, so this is your final answer, right? We're just adding the two functions. Okay, now in part C, right, so we want to do f times g of 5, and this just means I need to find f of 5 times g of 5. Well, we already found each of these earlier. We found that f of 5 was square root of 2, and g of 5 was square root of 3. All right, now again, we haven't talked about how to simplify this, but if you have two square roots being multiplied together, you can combine them and multiply their insides together. So this would just be a square root of 6. All right, now using that same logic, we can define, f times g for just regular x now. So again, this is f of x times g of x. So I need to do square root of x minus 3 times square root of x minus 5, times square root of 8 minus x. I saw the 5 in part A, and that confused me. But anyway, we can say that this is the square root of these things multiplied together, right? By the previous logic in part C, right? So now this just becomes a matter of foiling, right? And if you FOIL this out, let's see. So we get an 8x minus x squared minus a 24, and then plus 3x. So it looks like if we combine like terms, we'll get a negative x squared and a plus 11x, and then minus 24. All right, so that's our f times g of x. Okay, so now we're going to look at how we can express maybe a square root function as the composition of two functions, right? So the first thing that we would do to this, what you're doing to x, is first you're adding 3, and then you're taking the square root of those things, all right? So what we want to do is write that in terms of two simpler functions that correspond to these two steps, right? So one, we'll let f represent add 3 to x. And how do we say add 3 to x? Well, we say x plus 3. Right? And then we take the square root. So then to take the square root, we would just say that g of x is square root of x. These should be equal signs. All right. Now what we're going to do in a second here, when we talk about composition, is how we can sort of write that to combine these two. So combine f and g to give h. Right? And that's sort of the idea of composition. All right, so that's what we're going to do next. Okay, so we denote the composition of two functions, f and g, by sort of this open circle here, right? So you have f circle g of x, and we define that to be f of g of x, right? So it's like a function of another function. All right, and that's exactly what we're doing here. All right, so first I want to do a couple examples where we actually write a couple of these out. All right, now let's go ahead and let's look at this. So for part A, we want to find f circle g of 3, which means that I want to find f of g of 3. Right? Remember, whatever's closer to the number is going to be sort of your inside function. So first I need to find g of 3. Well, g of 3, my g is x here, x squared, so this is 3 squared, so this is 9. All right, so this means I'm doing f of 9, which now means go to f and replace x with 9, so this is 1 over 9 minus 4, so this is 1 over 5. All right, in part B, we're doing sort of the other way around. We now want to do g circle f of 3. So this is g of f of 3. So now I need to find f of 3. So that's 1 over 3 minus 4, which is 1 over negative 1, which is negative 1. So now this means I'm doing g of negative 1, which is negative 1 squared, right? Which is positive 1. Okay, now in part C, we want to find a formula for f of g just for general x. So we want f circle g of x, which is f of g of x. All right, so now instead of finding an actual number, I need to plug in my entire x squared there. All right, but that's fine. So I'm just going to f, and wherever I see an x, I'm replacing it with x squared. All right, so that's my formula for f circle g. Now, for part D, we're finding the other way around, g circle f of x. All right, so this is g of f of x. And that means that I need to do g. And what is f? It's 1 over x minus 4. And then, of course, g takes whatever is inside and squares it. So this is 1 over x minus 4 squared, which if you square the top and square the bottom is 1 over x minus 4 squared. All right. Now, part E and F wants the domain of each of these. Part E is the domain of f circle g. So we're looking at 1 over x squared minus 4. Well, of course, here you have a fraction, so you don't want the bottom to be 0. So we need x squared minus 4. When is that equal to 0? That happens when x is either plus 2 or x is minus 2, right? And we want to exclude them. So this domain is negative infinity to negative 2, negative 2 to 2, and then 2 to infinity. All right, but in part F, you have 1 over x minus 4 squared. So when is this not 0? It's when x minus 4 squared is 0, all right? Which, of course, is different from this, all right? And this would only happen when x is equal to 4, all right? So this tells us that our domain here is negative infinity to 4, and then union that with 4 to infinity. All right, so that's the idea there. All right, so just keep in mind too that in general, G circle F and F circle G, in general, they're not the same. All right, so that's one thing to sort of keep an eye out for. All right, now going back to what we said about combining some simpler functions to make the more complicated function, this is the idea that composition really looks to capture, right? So when we look for the composition of two functions, I want one function to be G, a separate function to be F, and basically if I take the composition, that's combining the two of those functions, right? So for example, G takes F to G of X, F takes G of X to F of G of X, and the combination of F and G would take me from X to F of G of X, right? That's sort of the idea. Okay, so let's look at this example. So in part A, we're supposing that our cell phone company charges $0.05 per minute plus 47 cents for each call to China. Find a function P that gives the amount charged by our cell phone company for a call to China as a function of the number of minutes. So in part A, hopefully this isn't too difficult, we want to do something like, so we'll say this is C of X is equal to 5 cents per minute, so that's 0.05 times X. And then you're always adding the 0.047. Oh, and I guess we're calling this P. So let me erase that. And we want to call this P of X. Okay. Now in part B, they want a function, so they're supposing that tax on cell phone bills is 6% plus 1 cent for each call. So we want to find a function T that gives your total cost, including tax, for a call to China as a function of the amount charged by your cell phone company. So of course we want T of X. All right. So now of course this is the total cost, including tax, right? So I need to take 0.06, since that's 6%, of whatever I did of my total cost, which is actually the first function, right? So it's 0.05x plus 0.047, right? And then plus an additional 1 cent. All right. And this is just for one call, so I don't need to do anything crazy there. All right. And if you want another way, you could write this as 0.06 times P of X plus 0.01. Okay. So now, and I guess the idea here is that they want x to be the cost, right, of the total thing. Yeah, so I guess I sort of misunderstood the directions there. But the idea is that we're taking in, as a function, amount charge. Okay, I see it now. So we're taking the amount charged by our cell phone company, and that's your x here. All right. Now part C is really getting why, if you take this composition, if you take T circle P here, then that is giving you the total cost, right? Because then you're going to get 0.0, so you're going to get what I had before, times 0.05x plus 0.047 plus the 0.01. And that's representing the total cost. All right, so now part D is write that as an explicit formula, and that would just be this part here, right? We sort of did that part. So now what is your total cost for a 10-minute call to China? That is just a fancy way of saying that x is equal to 10 in T of P, right? So this is T of P of 10, which is T of P of 10. So if we find P of 10, that's 0.05 times 10 plus 47, so 0.47, right? I realize I have an extra 0 up here. That should just be 0.47, right? So this is going to be 0.50 plus 0.47. So we get that this is 97 cents. All right, but now if we take T of 97, that's 0.06 times 0.97 plus 0.01. All right, and I guess this is just the tax amount, so I would actually need to even add another x to this. All right, and then plus 0.97. All right, so if we pull this up on a calculator, so we get a 0.06 times a 0.97 plus 1 cent plus 97 cents. It looks like the total cost for this call would be a 1 point, let's see, did I mess something up here? Oh no, so we get a 1.04 if we round. All right, so this 10-minute call to China would be $1.04. All right, so that's the idea there. Okay, now one thing that we need to discuss here is what's called the identity function. All right, and the identity function essentially says that if you put in x in, you get x to come out. So in other words, x is not changed. All right, you put in x, you get x out. All right, now for the composition of two functions, if you take f and you compose it with the identity function, it's just going to leave f alone, right? That's sort of what we're getting at here. So that's one thing to sort of keep in mind here as we move forward. Okay, now we're going to go back to this, this thing that we had before, where we want to try and write this function here, this t of y, as the composition of two simpler functions. All right, so we see that we have two things happening to y here. We see that y is becoming, so like y squared minus 3 over y squared minus 7, and then it's also, we're taking this, the absolute value. So we could say this in the form of a composition. We could say that f of y is y squared minus 3 over y squared minus 7. That's the inside part. And then the outside part is just take the absolute value of whatever you have, right? So it looks like we could say that this function is g circle f of y, right? Which would just mean g of f of y, right? And if you were to carry this out, just to be sure here, so we get a g, what is f of y? It's y squared minus 3 over y squared minus 7. And then what does g do? It takes the absolute value, so you get y squared minus 3 over y squared minus 7. All right, so you can always check that. All right, so that's sort of the idea there. All right, now of course you can extend this to 3 or more functions. You just have to do sort of one extra step there. All right, so we're going to look at the same function, except now we're going to break it into 3 separate functions. All right, so for example, you could think of the first thing you're doing. In this case, we're using x. So you can think of the first thing you're doing as the top part. Right? In the second part, you could think of, well, leave what you had in the first part. Let's see, is this the best way to do this? In the top and also in the bottom. But in the bottom, you need to subtract an additional 4. Right? Because in order to get x squared minus 7, you'd have to take your x squared minus 3 and then subtract 4 from it. All right, and then finally, your third step could be take the absolute value of this. So take the absolute value of whatever you have. So now if you combine this, you would have h on the outside, and then g, and then f of x. Right, because you want what's closest to closest to x to happen first, right? And you can verify that if you were to write this out as h of g of f of x and simplify this, do you actually get this? All right, so that would be one thing that you could check and verify. All right, but that's the idea, is that we can take this complicated function and write it as the composition of 3 simpler functions. Okay, so one type of function that we're going to talk about extensively in a future chapter is the idea of a linear function, right? So you're probably more familiar with if this is called y, right? And this is y equals mx plus b. This is a linear function. All right, not really too important now, but just keep in mind that we will study this quite extensively later. All right, but that's something that will come up when we get to it. All right, now I believe this is, okay, no, so it looks like we got 3 more examples. Okay, yeah. So these now all deal with how we can talk about transformations in the form of a composition of functions, right? So in part A, we want to write g as the composition of a linear function with f, right? So what's happening to what's happening to f? Well, g of x is -2 of x plus 1, right? As long as I define a separate function as f of x, right? So what this really means is that I'm taking g of f of x, right? And that would be my linear function there, right? So now, of course, part B is sort of a review of the previous video. How is the graph of g obtained from the graph of f? Well, the -2 stretches it by 2. And it flips it over the horizontal axis. And then the +1, of course, is going to shift it up 1. All right, so that's the idea there. All right, now in this one, we want to know if we can do the same thing. Can we write g as the composition of f with a linear function? So again, the idea is similar here. So now g is obtained by taking f of 2x, right? So now I would need something like this. I would need sort of like my f of x. I would need, let's see, what's the best way to say this? We could say, okay, so we could say, for example, the following. So if I take x and I make that 2x, that could be my function f, right? That could be or even we could take this as an h of x, right? And then we could take f of h of x. Yeah, I think that's the way we want to do it. And then that would be f of 2x, right? And that's what's equal to my g, which is f of 2x, right? So that one was a little bit tricky at first, but the idea is that you just need to affect the inside of f first, so you need to define a separate function that takes care of that. All right, and of course, part B of this, how the graph of g is obtained from the graph of f. Well, this is happening on the inside, so this is a horizontal stretch. But remember, this is really shrinking the graph, since that c is bigger than 1 by a factor of 2, or I guess of 1 over 2. All right, and last but not least, so we'll combine this, right? So in this one, we're going to need 3 separate functions, right? Because we could say that h of x is, again, that 2x, and that f of h of x is f of 2x. And then I need to add 1 to it, so we could say that g of x is x plus 1. And then we get something that g of f of h of x would give me this. Right, something like that. Okay, so, and of course, part B, how is this obtained? So it's so it's a shrink horizontally by a factor of 1 over 2, and a shift up 1. Right, and that's the idea. All right, so I think that's the last example, right? Yeah, okay, so that wraps up this video on composition of functions. I hope you enjoyed, and I will see you next time.